Hello and welcome to the ICS103 Programming course offered in KFUPM, that is King Fahd University of Petroleum and Minerals. My name is Akram Ahmed and I will be taking your class online, and this is the first lecture, and in the first lecture we're going to give an overview of computers and programming. Okay, so this is your book that you're going to be using in the semester. This is Problem Solving and Programming in C. Basically, we will in this class give you an overview of what we are going to learn about in this course, and we'll give you an introduction to computers and programming. Okay, so here's the outline of today's lecture. So today's lecture consists of an overview of computers, where we talk about hardware and software. Then we're going to talk about computer languages, software development methods, and then we're going to finally talk about Pseudo code and flowcharts. Okay. So let's start. So the first thing, what is a computer? We were working on C programming, so first of all we have to know what a computer is. A computer is a device, basically just like the one in front of you over here, that can actually receive input. So this is number one, it can actually receive. Then it can actually store. 3 is process, 4 is compute output information, so 4 is output. So it's any device, such as a device in front of you over here, that can actually receive an input, so it can take an input from the user, process it, store it, and display an output to the user. Okay, so anything that is in these 4 things is called a computer. Computers can deal with numbers, text, images, graphics, and sound. Okay, we make them do this because we want them to help us or aid us in manipulating and analyzing these things. That is why we make computers to work with everything else. Okay, so computer can deal with everything that you can actually imagine. Computers are worthless without programming. Why do we say computers are worthless without programming? Okay, programming is the way we talk to computers and give it instructions to do a specific task as we want it to do. So without programming, computers are worthless because it is something that you cannot give it a command or you cannot tell it what to do, so it won't do anything for you. That is why we say computers are worthless without programming. Okay, programming languages allow us to write programs that tells the computer what to do and thus provides ways to communicate with computers. So basically this is it. Computer programming is a means of communication or telling the computer of what to do based on our input. Okay. Programs are usually converted to a machine language. A machine language is nothing but a bunch of zeros and ones, so that computer can understand them. So the computer hardware basically understands only the machine language. It doesn't understand anything other than machine language. Okay? Going on, let's talk more about hardware. So what is a hardware? A hardware is anything that you can touch and feel on a computer, or you can actually plug it to a computer. Okay, so hardware is an equipment used to perform a necessary computation. So it's performing something for you, such as a CPU, which is the central processing unit, a monitor, a keyboard, a mouse, a printer, a speaker, or anything else, for that matter, that you can touch and feel, is called a hardware. A software consists of a program, okay, that enables us to solve problems. Okay, so you basically make a software when you want to solve a problem. An example of this is Word here, for example. MS Word, for example, Microsoft Word, is basically a program that solves the problem of word processing. So if you want to write a letter, if you want to write a memo, you actually use Word to do that. Internet Explorer is another program that actually solves the problem of internet surfing. So if you want to surf the internet, you go and start Explorer. Linux and Windows are operating systems that solve the problem of operating the hardware, and they abstract the hardware for us. Okay, and we'll go in details when we talk about programs in this. So computer hardware, let's talk about the main computer hardwares that we will be considering in this class. So there's something called the main memory, which is basically consisting of 2 things, the RAM and the ROM. Okay, so basically the RAM is a random access memory. It's a memory that can be accessed in any order. For example, in the RAM, suppose your computer has memory and it's allocated as a column. If you wanted to access column number 0, you can access it directly, 1 directly, 2 directly. In a sequential memory, to access 2, you'll have to read 0, 1, and then you will get 2. In a random access memory, you can actually go anywhere inside the memory and you can actually get the content of that memory. Okay? and we'll explain that when we go to it. So a RAM is a random access memory where you can read and write data anywhere you like. The most important thing about the RAM that it is a volatile memory. What do we mean by a volatile memory? It's a memory that when you plug the power off, everything inside it disappears. Okay, so the problem with the RAM is that you cannot use it or cannot store data in it if you turn off the computer. A ROM, on the other hand, is a read-only memory, is a memory that you cannot write to, you can only read from. Okay, it's usually written by the manufacturers of the computer and it deals with the hardware, so it is some things that you do not touch and do not change. Okay, so that is the read-only memory. We will not be touching too much on the read-only memory in this course, that's why I will concentrate more onto the RAM. So whenever we're talking about the main memory in this class, we are basically talking about the RAM. Okay, there are also secondary memories, just like the hard disk, the floppy drive, the disk drive, or CDs, DVDs, or any other type of storage mediums that you have. It may be a SAN switch that's actually storing a SAN storage, or it could be on the cloud and you're storing on the cloud. So all of them are called secondary memory. There's something called the central processing unit, okay, the CPU. The central processing unit coordinates all computer operations and perform arithmetic logic and operations, okay. So this is basically the brain of the computer. This is where all the computation and all decisions are taken, okay. So that is the most important part of a computer. There are input-output devices. Okay, an input device could be like a keyboard and a mouse. A keyboard and a mouse are input devices where you can actually give something to the computer. So when you want to input something to the computer, you either use a mouse actually, and when you use a mouse, you actually can click on things onto the screen and you can tell the computer that I am inputting something for you. And the keyboard, you can actually type something on the screen. Okay, so an output device could be a monitor or a printer. Anything that the computer can display an output for you, so it will use it to show you the output or the computation that it has done. Computer networks are computers that are linked together and can communicate with each other. Okay, so these are a bunch of computers, you connect them together and you can communicate with them. These are called computer network. We have different types of computer network. We have a LAN, that is local area network, where all the computers are in a local place or one place, just like in a room or in a building or university. You'd have a WAN, which is a wide area network, where there could be different locations where you want to connect. If you have, for example, an office in Riyadh, an office in Dammam, an office in Jeddah, or you have an office in a country and an office in another country, an office in a country, that's where you will use a WAN and connect these two together using some service that you'll buy from a service provider. Okay, there's also the wireless network, and most of you know the wireless network. You use it at home when you have the router and create a Wi-Fi network, and you can actually share all the data together at home or in a small location. Okay, so let's talk about in details and components of computer. Computer components are secondary storages. You have the main memory, the central processing unit, the input device, and the output device. So what happens when a computer actually operates? When a computer actually operates, the program is actually loaded from the secondary storage device to the main memory. So this is step number 1. Okay, so whenever you run a program or whenever your computer starts running a program, it actually goes to the secondary memory, fetches that data and puts it into the main memory. That is in the RAM. Okay, then the central processing unit is going to go start processing the information that is in the memory. So this is the step number 2, the central processing unit processing the things in the memory. When it's processing things, it's going to take the aid of the input devices and put something into the main memory. So if the user requests an input or the program requests an input from a user, it's going to take the input from the user and give it to the main memory, and the central processing unit is going to continue working on it. Then it's basically going to go and display the output for you. So this is step number 4. And if necessary, there might be, and that's why I'm putting this in dashed, there might be a storage. So this might be a step number 5 where you go back and store something into a memory. Okay, so this is how generally a computer works. It takes the program, goes into memory, the central processing unit then processes that memory, takes any input from the user, displays the output, and may store something back into the memory or the secondary memory. Okay, so this is how a computer basically operates. Now over here we're going to talk in details a bit about memory, and to start with the memory, I'll start with the middle of the slide over here where we define the bits. Okay, so the bits over here is the name of a common, the name comes from the binary digit. It is either 0 and 1. What is a bit? A bit is the smallest memory allocatable size. Okay, you cannot allocate a memory size smaller than a bit. So it's the unit of a memory, that's called a bit. Okay, A byte, on the other hand, is a memory cell that is actually a group of smaller units called bits. Okay, a byte is made of 8 bits. Okay, so a byte is made of 8 bits. Why did they actually select 8 bits to represent a byte? The reason for is that when they started the computer, they started looking at all the alphabets that they have to represent, and they gave each alphabet a number. So they started giving all the alphabets a number, A, a number, B, a number, C, a number, and they counted how many alphabets they want. So it turned out to be they needed 128 bits. Oh, sorry, they needed 8 bits, which is 128. Now the total number of alphabets in English might seem to be, for most of you, equal to 26 alphabets. However, you have to think of the capital and the small and the punctuation marks and all the other stuff. And when you count all of them, you're going to 128, and then you will get that you need 8 bits actually to store it in. Okay? And that is why a byte is of size 8-bit. Now we go back to the beginning of the slide and we talk about a memory cell. Okay? A memory cell, before we talk about the memory cell, let's talk about the memory of a computer. The memory of a computer could be visualized as a column or a row. You can visualize it as you like. I like the column way, so I'm presenting it in a column. So this is the memory of the computer. It is represented byte by byte. Okay, so you can see it. Each yellow box over here represents a single byte, and they are ordered and numbered. The number starts from 0 to the maximum size of the memory. So for example, over here, the first memory byte has an address of 0, the second memory byte has an address of 1, the third memory byte has an address of 2. Okay, so this is how the memory of a computer is basically organized. Now, a memory cell is an individual storage location in a memory. Okay, so the individual storage location in a memory could be 1 byte, could be 2 bytes, could be 3 bytes. Okay, so that is what's called a memory cell. We actually define a memory cell, and then we tell the computer, I want you to go 4 bytes for me, and that's my memory cell. Or you can say, define 1 byte for me, and that's a memory cell. So a memory cell is not a byte. It might be 2 bytes, it might be 3 bytes. It depends on the size of the memory that you actually allocate. Okay, so this is a memory cell, but it is actually an individual place, so it's just like a container. Okay, so if you have big numbers and you cannot store them in 1 byte, you will have to have a bigger container to have them 2 bytes, so you'll define a memory cell of 2 bytes. If you have small numbers, you'll define a memory cell of 1 byte. Okay, if it's a very large number, you might define 4 bytes, 10 bytes, depending on the memory size that you want. What is the address of the memory cell? The address of the memory cells are the numbers that are written over here. 0, 1, 2, 3, 4, 5, 6, 7, 8. The memory address always starts from 0 and it ends at the maximum size of your memory minus 1. So basically, in this example, we have 9 memory locations, and we have numbered them from 0 to 8. That makes a 9. Okay, so this is the address of the memory cell, or the memory content. Now, the content of a memory is an information stored in the memory cell, the program instruction data, or anything else. So what is the content of the memory cell? It's what's inside the memory cell. Okay, so example over here, memory cell address number 1 contains number 10, number 4 contains X. Okay, and this is the content, is what's inside the memory. That is what is the memory content. Okay, so the memory cell, we defined it to be something, a memory storage, a storage space where you can actually store something. An address of a memory cell is the address as shown over here, and the content of the memory cell is what is inside that memory cell. Okay, now it is very important to note that every memory cell has a content. So every memory cell has a content. The question is, do we know that content or we don't know? Okay, now why does a memory cell always have a content? It's because of the smallest size of a memory is a bit, and a bit can either take a value of 0 or 1. Okay, so it's either 0 or it's either 1. It cannot take any third value. So when you start your memory, it might be that your memory is all zeroed out, so everything in it is written in 0. So you go to memory cell 0, for example, the first address, and you get the memory and you find the value, will be 0. Okay, it can be all set to 1. It depends on what the operating system is doing, and since we don't know what the operating system is doing into the memory, we cannot know what is the value. So whatever is in the memory cell, sometimes we know it, sometimes we don't. When do we know what is in the memory cell? We know what's in the memory cell if we set that value. So for example, if we set the value of memory address 1 to 10, we know it contains 10. If we don't set any value, that means that the memory cell contains random value. Okay, So I'll explain this once more. Every memory cell has a content. Whether we know it or not, that's a different question. Okay? The memory cell contains always a content because the bit can be either a 0 or a 1. So the value the memory cell can actually take is all zeros or all ones or any value between 0 and all ones. Okay? Now when we start a computer, all of these are set at random and we do not know what the values are in them. We only know the values that are in them when we set the value. So if we put the value 10 in memory address number 1, we get the value 10 inside it. Otherwise, in memory address number 0, we don't know what the value is. Okay? So going on. Computer software. What is a computer software? We talk about first the operating system. The operating system controls the interaction between the machine and the user. Example, Windows, Unix, DOS, or any other operating system that you might encounter. Okay? So what does the operating system basically do? The operating system sits between you and the hardware. So if you have the hardware, and this is where you have the hardware, and this is where you actually lie on top. So it is sitting between you and the hardware, and it's controlling the hardware for you. And these are the 4 things that it basically does. This is what the operating system does. It communicates with the computer user. So it is basically the program that is actually taking the inputs and output and displaying the outputs to the user. Okay? It manages the memory, so it actually goes to the RAM and it manages it, so you do not have to take care of all the memory of the computer. Okay? You will only manage the memory of your program, but you do not manage the memory of the computer. So management of the memory is something that the operating system does for you. It collects input and displays output, and it writes data to the secondary devices. Okay? So let me take an example over here. Suppose that you run a program, suppose a word editor that you run on a PC, and in the word editor you type W. Okay, so what's going to happen? As soon as you type W onto the keyboard, a signal is going to be sent to the computer, and the computer is going to know W was sent. It's going to send it to the operating system and tell it, hey, the user pressed W. The operating system is going to take a W and then give it to a word editor program. The word editor program is going to receive the W, confirm the reception, and then tell the operating system, okay, I want you to go now to the screen and display the W for me. So a W is going to appear in the word editor that you have. Okay? And this is exactly what's going on in your computer. Now, application software, these are developed to assist the computer user in accomplishing a specific task. Example, Microsoft Word is solving a problem for you of word editing. Excel, for example, Internet Explorer is solving for you the problem of internet surfing. So these are application programs. They are over here. They're on top. They run on top of the operating system, and they utilize the operating system to actually get information for them. Okay? Now we come to computer languages. So as we spoke before, we have hardware in a computer, and the hardware of a computer only talks the machine language. Okay? So what is the machine language? A machine language is a collection of binary numbers. It's a bunch of zeros and ones. Okay? The problem with machine languages, it's not standardized. Okay? There is a different machine language for every processor family. Imagine how many processors are there in the world, and each processor has, or each processor family has a different language. Now for programmers to write a program on each processor becomes very difficult. Okay? So the problem with it, it's not standardized. Okay? There is no standard governing the machine language. The only people who know the machine language are the people who actually manufacture the hardware, or the people who are writing the compiler code. Okay? So these are the people who know the machine language. So machine language is something that we will not touch upon in this course, but you have to know that the hardware only and only understands the machine language. Okay? So the next level of language is an assembly language. Okay? An assembly language is a language that is very close to machine language, but instead of all zeros and ones, they added some English words in it, just like add, subtract, and they have special words that you can actually use in the assembly language. However, the assembly language is very close to the machine language, and it actually maps the machine language directly. Okay, so one instruction in machine language is equivalent to one instruction in assembly language, and that's why if you have to do an addition in a machine language, you might need something like 50 lines. In assembly language, you'll also have to use 60 lines of code actually in assembly, written in assembly, to do the addition. Okay, it's a very low-level language and very close to the actual machine language. Then they came up with something called the high-level language, and that is what we are going to learn. Okay, the high-level language combines algebraic expressions and symbols from English. Okay, that's the beauty of it. You can actually write mathematical equations in it in an algebraic way, a specific way, and you can use symbols to actually denote for you. So you can put X, Y, Z. Okay, and over in the assembly language and the machine language, you cannot put X is equal to 5 plus 4. You will have to specify a memory address, and that will become too problematic. Whereas in high-level language, you can say X is equal to 5 plus 4. Okay, and that will do it for you. A high-level language is very far away from the actual machine language. Okay, so the high-level languages are very far away from machine language. That is a problem, okay, because the hardware only understands the machine language. I'll give an example of a high-level language: the Fortran, COBOL, C, Prolog, Pascal, C#, Perl, Java, .NET. Any other programming language that you can actually think of is actually a high-level language. Now the problem occurs over here is the high-level language is very far away from the machine language. How would a hardware understand what is written in a high-level language? Okay, and to explain this, we made something called a compiler. A compiler is a software that actually translates the high-level language to machine language. Okay, so we write our software in high-level language, then we compile it, it generates for us the machine language, and we run it so the hardware can understand it. So the compilation process is the process of translating the source code, which is of the high-level language, into an executable code called the machine language. A source code is anything that you write in anything that you write in high-level language is called a source code. So the source code, a high-level language produces a source code, and the source code actually needs to be translated to machine language, and we use a compiler to do a compilation for us. Okay, so let me give you an example. Suppose we would like to do an addition. So we want to take two numbers, so input two numbers, and then we want to add two numbers. So we're doing, I'm doing my addition over here, and then we say display output. Okay, so these are three steps we want to do in our program. Okay, so first of all, we'll have to make a source file. This is a file that contains the program code or the high-level language code. Okay, so these are source files, for example, over here that I'm showing you. Okay, so suppose I have different source files. I'm going to use one source file to take the input, one source file to add two numbers, and one source file to display the output. Okay, a compiler turns the source file into an object file. So what does the compiler basically does? It does two steps. It says compilation and it does linking. First of all, when you compile a source file, the compiler is going to go take the source file and try to understand what's written in it. Okay, so it's going to open the source file and it's going to read in it, and it's going to see if it understands what's going on or not. If it understands what's going on into it, it's going to generate an object file for you. This is a machine language code. Okay, if it doesn't understand what's written in it, it will raise an error and say, I do not understand. That is why you have to learn coding. You have to learn to type in a way in the source code so that the compiler can understand it. If it doesn't understand it, it generates an error. Okay? So if it understands everything successfully, it will generate a machine language for you. This is a bunch of zeros and one. The other source file for adding two numbers is going to generate a machine language for you, and displaying an output is going to generate the machine language for you. Okay? Then after the compilation comes something called the linker. The linker puts everything together. Okay? So suppose you wanted to add two numbers. So we'll ask in this first source file to input two numbers. Now suppose by mistake you inputted three numbers over here, and you give it to the second source file to do the addition. The compiler is going to look inside the second source file and it's going to say, okay, while I'm doing the linking, I need two numbers to be added over here, whereas in the source file over here you've written three numbers, so you're passing three numbers from here to here. The compiler is going to look at this and it's going to see if it can actually take input from the user, because this file is for the input of the user, and it's going to compile it fine because you asked for the user to input three numbers, and the compiler can understand the code that is written in it correctly. The second source file is for adding the number, and in here you add two numbers, and when the linker comes, when you finally link these two together, the linker is going to look at three numbers coming here, two numbers are coming from here, and he's going to say, wait a minute, I'm going to have to add two numbers, but you're providing me over here three numbers, so it's going to throw an error for you. It's going to generate an error, and it's going to say, I'm getting three numbers where I'm expecting two numbers over here, so this file and this file cannot talk to each other. Okay, so the linker makes sure that these object files can talk to each other and then generates an executable program. If in the case of our example you had three inputs over here and two to add, the linker is going to generate an error. You're going to go back, update your source file with two inputs, and then the linker is going to look at two inputs are coming from here, two inputs are being added. So it's going to say, okay, these two can talk to each other now, and it's going to go and generate an executable file for you. Okay, so an object file contains a machine language instructions. A linker turns the object file into an executable code. Okay, so a single code by itself is not executable because it does partial things. So this is the divide and conquer. So you divide things into different source files, and then you compile them to create different. You divide things into different source file. You compile it to make different objects, and then the linker makes it one file for you that does everything for you. Okay, now you can actually go and get an editor, a word editor, and actually write a source code, and then you can get a compiler to compile the object file for you, and then you can get a linker to link all the object file for you. Okay, but this makes a hassle for the programmer, and he has to have a compiler, he has to have a linker, and he has to have an editor. So they came up with something, a neat thing called an integrated development environment, an IDE. And in the IDE, what it happens is the program combines a simple word processing, compiler, linker, and it puts everything for you. So what you have to do is go inside, open the IDE, and then type your source code, and then there's one button that you click. If you click it, it's going to compile it and run it for you. So compile, link, run. So everything is in one place. That's why they call it an integrated development environment. Example of this is Eclipse, Visual Studio. You'll be using Dev C++ in our class. Okay? Now, so here's how the program is basically started and written and run. So you have a word processor, and in the word processor you actually type in the source code or the instructions you give to the computer. Then you have a source file, you give it to the compiler. The compiler attempts to understand what's written inside this file. If it understands what's written inside this file, it's going to compile it and generate an object file. Otherwise, it's going to report an error. It's going to generate an error and tell you, I do not understand what you have told me in this source file. Okay? If it understands, it's going to generate an object file. Then the linker takes it and links all the object files that you have together and sees if they can actually talk to each other. And if everything is resolved, it's going to generate an executable file, and the executable file is something that you can run on your PC. Okay? So this is basically something pretty simple. Now, how does the flow of information in a program goes when you are executing a program? Okay? So when you execute a program, what happens is that you read the data and you actually allocate, the operating system when your program runs actually allocates a memory for you. Okay, and this is the memory it allocated. In the memory is going to put the machine language code that is generated in the executable file, and it's going to reserve a place for the data entered during execution. So all the memory for the data that you enter during execution, and a place for the result. Okay, so what's going to happen basically is the central processing unit is going to start doing the machine code. So that's step number one. Step number one is executing machine code. So it's going to start executing, it's going to read the machine code and it's going to start executing it. And it's going to take step number two, an input from the user. Okay? So the input is going to come from the user, and all the input and the instructions will be given to the central processing unit. Okay? So then what is going to happen, the central processing unit is going to go and do the calculations required, the addition, subtraction, multiplication, whatever is required, and then it's going to go and store the output into the memory. Very important thing to note is when you input data to the computer, is stored into the main memory, which is the RAM, okay, which also contains the machine code, and when the processor processes the data, it stores it into the main memory again. and then it outputs the data for you onto the display or any type of output device that you tell it to output on. Okay, so here's basically what happens. Allocate a memory. This is the machine code. You get the input, you give the machine code and the input to the central processing unit, it generates an output, and then you basically display the output. Okay, now we talk about the software development methodology. How do you actually develop a software? First of all, you have to specify the problem requirements. Okay, this is also referred to as the software development lifecycle, but this is we'll call it the development method. So we specify the problem requirements, so you have to understand what the problem is, and this course is going to be easy. We're going to give you a question and say write a program that does 1, 2, 3, 4, 5, and you have to do the 1, 2, 3, 4, 5, so the problem is actually specified. Then you have to analyze it, then you have to design it, then you implement it, test it, and then you maintain it. Okay? So, talking about the steps in details. So problem specifying the problem requirements forces you want to understand the problem more clearly. So in the problem, just read it and make sure that you understand it crystal clear. Okay? Then you have to analyze it. What do you do in analysis? In analysis, you look at a program and then you say, okay, so I want to write a program. What should it do? It should do 1, 2, 3. Okay. Now, how many inputs do I have? Where am I going to get the inputs from? How am I going to go from the inputs to the output, and what am I going to do to the output? So you count the number of inputs, you count the number of outputs, and you look for any supplementary data that you might require to go from the input to the output. Okay? If this sounds Chinese for you, it's okay. I'm going to have an example and I'm going to explain it to you in details. The design. Designing the algorithm to solve the problem requires you to develop a list of steps called algorithm. So what is an algorithm? An algorithm is just a simple way of saying make it a step-by-step procedure. Okay? So it's a step-by-step procedure from going to from the input to the output of the program that you require. Okay? So it's a step-by-step procedure to solve the problems, and then you have to verify the procedure at the end after you write an algorithm that it is doing what you are actually requiring to do. The implementation part, here is where you actually come and do coding in C. So all of this, prior to this, you're actually doing something that is not related to C. You have to do the problem, the analysis, and the design for any problem that you have prior of actually starting writing the C code. Okay? So in the implementation, you write the C code, and in the testing, then you test it and you give it input that you know the value of the output if you give it. And for example, if you are testing multiplication, you will give it 5 and a 10. You expect the output to be 50, and you give it the numbers, and you see if the program is doing what it's supposed to do. If it generates a 50, that's fine. If it doesn't, then that means that you made a problem. Then you have to go to the source code, check what the problem is, correct it, and then recompile everything and do it again. Okay? Maintenance, finding problems that were undetected, just like what Windows does. It sends a patch for you every month or so. Microsoft sends a patch for Microsoft Windows, and that is for maintaining a software. Okay, so let's take an example. The example is converting miles to kilometers. So suppose you go to your job and your boss wants you to convert a list of miles to kilometers, and since you're good in programming and he's seen your CV that you've taken this course, so he wants you actually to write a program to do the job. So you know the problem. The problem is very simple. Converting miles to kilometers. So let's analyze. What are the things that we have to do in this? The first step is we have to know how many inputs do we have, and we need to get the miles from the user. So we have only one input because we're going to write a program that takes one input and generates one output, and we need to get the miles from the user as an input. What are the outputs? The output is the kilometers. So we need to output a kilometer. So we input miles, we output kilometers. Do we need anything else? Yes, we need to know how many 1 mile is equal to kilometers. So we know that 1 mile is equal to 1.609 kilometers, and you get this from the book. In the real life, if you're there, you can actually search the internet, or you have to have another mean where you can actually get this data from. Okay? So these are the analysis steps. Then we design. What do? We say get the input from the user in miles, so get the distance in miles, convert it to kilometers, and display the kilometers. You see, the algorithm is a step-by-step procedure going from miles to kilometers. Here is the implementation in C. Okay, I'm not going to go into the details of the implementation over here because we're going to be teaching you, but I wanted you to actually have a feel of what the implementation actually looks like. Okay. Now the numbers over here are the number of line of codes and not the memory addresses. So we need 24 lines of code actually to convert kilometers to miles. And then when we run the program, it's going to enter a distance in mile, and we enter 10. It's going to say that equals to 16.090000 kilometers. And this is how we asked it to produce an output. After we do this and we implement it, we have to do a test, and we have to stamp it that this thing works fine. So we need to give it numbers that we know the output of. So in our case, in the last case, we gave it 10 because it's easy for us to calculate. So we calculate that offhand by hand, and then we give it to the computer, and the computer then runs the program and then make sure that the output of the computer is matching to the output that you have it by hand, and that is going to make it a tested program. In the maintenance, next time your boss gets a contract with NASA, so you might be loading this into a shuttle. Okay, and NASA might require some maintenance from you, support, converting it to other type of platforms, so you'll have to add a support to it. Now, the last thing in this class that we're going to discuss is the pseudocode and flowcharts. Okay, so let's basically define pseudocode. What is pseudocode? A pseudocode is a combination of English phrases and language constructs to describe an algorithm steps. Okay, so it's basically something that we write in English to help us try to understand what the problem is and how we are going to go from one step to another, or from the input to the output of the program. Let's define also a flowchart. It's a diagram that shows the step-by-step execution of a program, and an algorithm is a list of steps solving a problem. I'll go in each one in detail. Okay, so pseudocode. Okay, pseudocode cannot be compiled nor executed. So why do we actually write pseudocode? Suppose that you go in future in a company and you're developing software, and they put you in a team where you are programming in C, another person is programming in Java, a third person is programming in Perl, and a fourth person programming in .NET. And you guys want to sit and make an algorithm. If you write your algorithm in C, the other people will not understand it, especially people who are using Java, Perl, because they do not understand what the syntax of C is or how C is written. Okay, and if they write their code in Java and give it to you, you will not understand it because you only know C. You don't know how the word syntax is written in Java. So they made something called a pseudocode. It is simple, one step in producing a final code. The benefit of pseudocode is that it enables programmers to concrete on the algorithm without worrying about the syntax details. Okay, so first of all, when you're doing the algorithm, you want to concrete on the problem. You want to solve a problem. Okay, you don't care about the syntax of the code and what exactly the syntax is, but you want to solve the problem. That is why when you discuss with people and you want to tell them, okay, to do this, we are going to use these steps. You give them a pseudocode. You say, first I'm going to do this, then I'm going to do this, then I'm going to do this, then I'm going to do this, and finally I'm going to get the answer. Okay? So you don't have to write code for it, but you write something called a pseudocode. Okay? So it's English constructs and words. Okay? An example of converting the miles to kilometers is if you say, first of all, we'll input miles, then I'm going to calculate kilometers equals to miles multiplied by 1.609, then we'll output kilometers. Okay? Now this is, you can understand it, everybody can understand it. This is not written in C, so this is called pseudocode. Okay? It's easier for everybody to understand and collaborate, then people can comment on it and can say, give you an output on it. Okay? Another example of pseudocode is calculating your final grade for ICS103. Okay? So the problem is you have to get the different grades. So let's analyze this problem. The problem is you want to calculate your final grade for a class, for example. You want to specify the problem and you want to analyze it. Okay? So specifying the problem, you get different grades and then compute the final grade. That's very, very trivial. So you have to get all the grades, the different grades that you get in a course, and you have to add them up together to get the final grade. Now when you analyze a problem, you say, okay, how many inputs do I have? What do I have? I have a lab test, I have a quiz, and I also have a final. Okay? Midterm and finals, exams, all of them, I have them. In addition to this, I need to know the percentage of each part. So how much does a homework constitute out of 100? How much does a quiz constitute out of 100? How much is the final out of 100? And how much is the midterm out of 100? Okay? So we have to get all of these data. So you'll go into the course syllabus and you'll get all the data. And then you design, you say get grades, so quizzes, exams, labs, whatever grades that you want. This is a pseudocode example. Okay, so get the grades of exams, quizzes, and labs. And the grade is equal to the weight multiplied by the value. So it's 0.3 for 2 regular exams and quizzes, plus 0.2 for the final and 50 for the lab. Each course might differ, so you can actually go to the syllabus and get this in it. Then comes the implementation part. Okay, so you go and implement it in C, and I'm not going to show you the code of C over here, simply for the reason that we wanted to give an example of a Pseudo code, which is actually shown over here. Now, you don't have to be a C expert or even a beginner in C to actually understand this. You might have no knowledge of C, but you do understand this, okay? And we write this way because we don't want to care about the syntax of C, but we want to solve the problem of getting from the input to the output. Flowcharts. Flowcharts, on the other hand, are a graphical representation, okay? So it is a graphical representation of a process or a step-by-step execution of a program, okay? The flowchart has different shapes. A rectangle shape is for a process. This is for a decision. This shape is for the display. The oval shape is for the start or the terminate. This is for a document, and this is for a manual input, okay? So let's take an example of a flowchart. So as soon as I see a flowchart, it might be something very big. This is a very small flowchart, but it might be something very big. I start looking for oval shapes. Why? Because the start and the end are in the oval shape. So I start from there, and then I follow the arrows. So I have the start, and I follow the arrow. Okay, so this is where my program is going to start from. Then I say, get grades and percentages. So this is the example of calculating your grade. So we get the grades and percentages, and notice this is in the shape of actually an input. A manual input, so we get a manual input, so we exactly know from the shape that we are going to get from the user the inputs of the grades and the percentages. Then we have a rectangle. This is a calculation, so we calculate the final grade. Then we have an output which will display the grade on, and then our program actually ends. Okay, so this is a flowchart that actually makes things easier for you and actually gives you a graphical representation of how your program is going to run. Okay. Now, in any program that you write, first you have to start, then you have to get the grades and percentage, you have to get the input, then you calculate, then you display the output, then you stop. Okay, so this is a sequence of any program in your life that you're going to write. Get the input, calculate it, display it, and then stop. Okay, and with this we come to the end of our first lecture. I hope you guys actually enjoyed it. And we'll see you next time on the second class.